Alright gang, this one's the exact area, so we're going to be using all these formulas over here, okay? So when you're doing the exact area, you start with the delta x formula. Delta x again is the length of the interval over n, so that x sub 2 minus x sub 1 over n, or right endpoint minus left endpoint over n. So length of the interval, so right endpoint minus left endpoint over n. It's 1 over n. Okay, then the next thing you calculate is delta x I. Oops, sorry, it's a little I here. Delta x little I. We're doing the name over here. Alright, and that is defined as your start point, or your x sub 0, x sub 1 I should say, plus delta xi. I wrote that down. Oh, I didn't write it all. I should have written it more here. Okay, start point plus delta xi. You need the I on there. Alright, so the start point is 0 plus delta x is 1 over n. You've got to times that by I. So we're going to write this as I over n. Alright, now you're going to put it into the big formula. Alright, so here we go. Okay, x sub I we calculated as I over n. That, again, that I is so that you can iterate across the x-axis. The 1 over n is the width that you iterate. The I is you iterating. First iteration, second iteration, third iteration. Alright, times delta x, which is 1 over n. Alright, now you actually have to put this into the actual function. So the function in this case is this guy here. Okay, now like I mentioned before with the sigma, you need distinct terms, so you don't want this product here, so I'm going to actually distribute this in here. Okay, so now I have two distinct terms, and this is the part where I give the sigma to each. You don't actually have to write that step out. I just like being really clear. You could just know that this sigma is applying to each. And the part that it's applying to. So like for instance, when we look at our summation formulas, alright, for that first one, since it has an I in it, we're going to want to go to this one here, okay? This is where we're now going to break it up because we're going to end up using the sigma formulas. So I'm going to put the -4 and the n squared in front. You don't have to write this extra step. I just want to be really clear with the students that this is what I'm replacing, and then that carries along. Alright, for the next one, there is no I here, so it's the constants, the only thing I really have. And it gets a little confusing to students, but when you're doing sigma, I is the variable, not n. N is like what you're going to. So like if you're going to 10, n is 10. N's a constant when you're doing sigma. N's a variable when you're doing the limit. So the variable for sigma is I, the variable for limit is n. Alright, so this is where we do the replacement. Alright, so the formula for I, so I'm getting it from over here, okay? So this one here. So that n plus 1 over 2. So I'm replacing this whole thing with that. Now over here, I'm replacing this whole thing with this, except that the constant is 5. So you're going to see me write 5n. Now it's up to you. Some people simplify a bit at this stage. I don't really. I would if I thought it would be very helpful, but I personally don't think it is. So again, it's up to you. Some people might find it a lot easier. I mean, you can simplify here if you want. Like, you can reduce an n, you can reduce the 4 and the 2, you can reduce an n. Okay? It's just up to you. So the degree of this numerator is 2, because when you do this, you're going to... Oh, maybe I will do a little bit of work here. This just took me a second to distribute, so I just went ahead and did it. Alright, so it's degree 2 over degree 2. So remember from limits, if it's top, remember top heavy, bottom heavy equal in degree. This is equal in degree, so it's the ratio of the coefficients. So for the first fraction, the limit of the first fraction is negative 4 over 2. The limit of the second fraction is also equal in degree, so it's 5. But if you had reduced it, you know that the limit of a constant is a constant. Alright, so you're basically getting negative 2 plus 5, which is 3. That's the answer. I also taught you guys that you can check your answer using the integration. I'm not requiring you to do this, but you can check it. So just because this method is so long, it, you know, oh, hold on, I need a dx. Alright, so if I integrate this, this is negative 4x squared over 2 plus 5x. No plus c because it's a definite integral. Let me just reduce this. Now I'm just going to plug in the 1, upper limit minus lower limit. Alright, what are we getting here? Negative 2 plus 5. And then this is 0, so this is 3. Alright, which is what we got. But anyway, that's just like a nice way to check it if you want to then use like a definite integral to just double check it. Alright gang, that's it on this one. Catch you. Bye-bye.